This lesson starts with, I have no clue. This lesson starts with looking at this lab that we did. We had one example where we rolled the ball just sideways along the ground, and it showed up with a kind of a velocity that we see here. This is a velocity over time graph, and it's kind of off because we were just kind of putting points with our fingers. It wasn't very exact, but we can see it, a pretty good trend line right there. A nice constant velocity. Now, if you compare that to when a ball was falling, and we see this kind of change in design as the ball falls, it's really crammed up over here and starts to spread out over here. When that shows us we have this velocity that's going faster and faster and faster downward, where it started at, say, 2.5, it finished at beyond 10. The negative just means downward. So we see one example where velocity is flat, one example where velocity is changing, and that's because, well, it's being pulled down by gravity more and more and more all the time. And there's a term for that. It's called, well, acceleration. So what is acceleration? Acceleration describes an object's change in velocity during a specific amount of time. That is to say that when an object is speeding up or slowing down. If the velocity is changing, an object is accelerating. The units are meters per second squared. So if an object is accelerating at -3 meters per second squared, then the object is getting 3 meters per second slower each second. Well, what does that mean? Well, let's take a look at this little car I drew. Let's say this thing has a velocity of 12 meters per second here. And then during 1 second goes by, and its velocity is now 3 slower. It's hitting the brakes. Now it's at 9 meters per second. If we go another second, then it's going to slow down another 3 meters per second to 6. Another second, it will be 3, and finally it will be at 0, or come to a stop. So this is when an object's accelerating. It's slowing down. This could just easily be backwards. It could be speeding up 1 second, 3. The next second, 6, 9, and 12. That would be positive acceleration, speeding up. But the important thing is, do you know that that means if you see this, that means the meters per second square means it's going this much slower each second. That's why seconds are squared. What does this look like when we graph it? Well, if it's a velocity over time graph, then as long as the slope isn't 0, that would be accelerating faster, positive acceleration. This would be negative acceleration. It's going slower each second. This would be 0 acceleration. This is like sitting on the highway going 60 miles per hour. You're not speeding up, you're not slowing down. This down here would just be stationary. You're not moving at all, you're sitting in your seat. Well, what if it's distance over time, or position? Well, if we start at rest, and then after 1 second, we're going, let's say 2. And then you increase the next second, and the next second you're going even more distance in the same amount of time. Slow, faster, faster still. What we see is we see this curve. And that, in a position over time graph, that would be speeding up. Slowing down would be like this, coming to a stop. Finally, we can even use a graphs to do it with a little bit of math. How fast is an object going after 5 seconds if its acceleration is 3? 1, 2, 3, 4, 5 seconds. 0. After 1 second, it would be 3. After 2 seconds, it would be 6. Oh no, I'm going to run out of space. 3, 6, 9, 12, 15. It would be way up there at 15 meters per second. So you can just kind of count it up on a graph. That's your intro. What is acceleration?